Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, students. I am Farough Ahmed Siddiqui, your instructor for this revision session on functions, a part of your P1 syllabus, that is your AS Mathematics P1. And in this video, I'm going to use some basic ideas about the topic of function. In the next video, I will be adding a few more topics about the transformation of function. Then you'll be joining my session, inshallah, on 5th of April for doing some past papers on the topic of function. So starting the session, student, the first thing is few guidelines to gain to get the best result from these videos. You watch the videos, you get 2 or 3 videos here, read the slides. Whenever you see some concept is not clear, pause the video then and there and repeat that part, take notes and then proceed and try to solve the examples. If you find examples in these videos, pause the video there, first do yourself those examples and then see my working. Practice this topic after every video and from your reference book or textbook, whatever book you are having for P1 math syllabus. Please do some practice question from that book or those books. And finally, if you have any query, if you have any problem, you bring your problem during my revision session. If you still have queries, you can post your queries on our Facebook page of Easy Taleem and you get your replies, inshallah. And this is very important. There's only one way to learn mathematics, that is to do mathematics. Practice, practice, and practice. Now moving to the learning objectives of my lecture, what I'm going to cover in these lectures. I'll be defining the term function, the term variable or the term relation, and then range and domain, these terms. So we will learn some vocabulary of this topic of function. Then we'll be doing some graphical representation, vertical line test, types of function by doing the horizontal line test. Then we talk about the composite function, then the inverse function, and few sketches of function, again very important. And finally, we will be doing the past papers question to the extent of P1 syllabus only. Now, function. Dear, function is not the every relationship is a function. For example, if I'm writing y equals to x, it's a function. If I'm saying y equals to x squared, it's a function. If I'm saying y is equal to sine x, you know it's a function. But if I'm saying y equals to, suppose y squared is equal to x, it's not a function. I will tell you why. So every relationship is not a function. So for function, there must be some characteristic property, and that property I'm going to discuss in this slide. And you need to know two things here about two terminologies. When you input some value in the function, it is called domain or your x value. The output is known as image or the range of the function. Please note down these few properties. So function is defined that you are putting a value in the relationship and you're getting some output, a unique output like this. This mapping concept is very important to understand the idea of the function. That is, for every input, if you're getting only one output, for every one value of x, if you're getting for one value of y, for every domain, you have a one value of range, for every element, you have one image. I've used different words: domain, range, input, output, element, and the image. So the main idea, for every x, if you're getting only one value of y, this is a function. But for one value of x, if you are getting multiple values of y, it is not a function. So this is the definition of function. The inputs values are known as domain, the output values are known as range, and treat the function like a machine. Like in a process, in a machine, in a factory, you have some inputs and then you are having some outputs. Like if you have a yarn machine, spinning machine, so your input is cotton and the output is yarn. Same in mathematics, you have some inputs into the function. For example, can you say demand is the function of price? If you have different prices, you get different demands. So there are multiple things. For example, sine is the function of angle. At different angle values, the sine ratio is different. So this is the definition of function. That is, if every element in domain is mapped only or exactly one element or the range, this is called a function. right? And such function with one input, we have only one output, you call this as a one-to-one function. Note down the definition of one-to-one function. If I am using one value of x and getting only and only one value of y, and this value of y not possible for any other value of x, it is called a one-to-one function. And always treat the function like a machine, like a process. Like this also function, you see here, for one value of x I get only one value of y, for this value of x I get one value of y. When x is 1, y is 1. When x is negative 1 square, y is 1. When x is negative 3, 3 squared 9, or negative 3 squared 9, for every one input I am getting one output. So this qualifies the definition, the condition of the function. But you are seeing here, this is not a one-to-one function, it is a many-to-one function. That is, for one value of y there might be multiple inputs possible. You got the idea? It's a many-to-one function. This is not a one-to-one function. In case of one-to-one function, you have mapping for one x with one y only. But here with two possible x values, you get one possible value of y. So first you should understand the meaning of function, then you should understand the two types, one-to-one and many-to-one function. And one-to-many is not a function like this. Here this one input giving you multiple outputs, you're getting two outputs. Like root of x with plus and minus. If I say y square is equal to x, if x is, suppose if x is 2, you get root 2 y value and minus root 2. If I take the value of x as 2 here, the value of y can be root 2 or negative root 2. So this is not a function. So one-to-many is never be a function. Pause the video here. At least run through these two slides first. These two slides form the basic or the foundation of this topic. Unless and until you got this idea clear, what is a function and what are one-to-one and many-to-one function, do not proceed further. And the two terminologies about the range, that is input, and domain, about the domain, which is the input, and range, which is the output of the function. Student, you can get the idea of the function by having graphical approach also. You see, I've shown different graphs on the screen. This is called the linear graph, straight line. Suppose y equals to, just example, y is equal to suppose 3x plus 7. Suppose, I don't know what is the intercept here. A graph which is quadratic function, graph cubic, degree 4 x4. This is graph 1 over x, and this is a graph of sine function. Sine is also a function. And you see very interesting thing, how to identify that feature here, or that how to check that feature or identify the given graph representing a function. Because for a function, for every input of x you have only one input of y. Note down this. For every input of x you have only one value of y. This can be tested by involving a vertical line test. You see, I've drawn few vertical lines here, and every vertical line intersecting the graph only and only one point, unique point. It shows that with this value of x I have only one value of y. With this value of x I have only one value of y. With the value of x here you have just one value of y. This is called a vertical line test. And the vertical line test gives you a clear idea whether the graph representing a function or not. If your vertical line is intersecting at more than one point, like this, these two graphs are not representing a function. I've never said circle function, because circle is not representing a function. You know the definition of circle, how to write it, x square plus y square. Here the radius is, suppose it is 2 square 4. This is not a function, because when you make y the subject, you get plus minus under root 4 minus x square. With one input you're getting multiple outputs. Same is here. So this is called the vertical line test, that can be used to check whether the graph representing a function or not. So you got the idea clear. All the relationships are not necessarily a function, because there are some connections, some relationship. For example, y square is equal to x. It's not a function. But every function is a relation. You are relating to it. There are two different terminologies, relation and function, between the two variables. So when you have a relation with one value of x with one input, only one output occurs, it is called function, and we can check graphically with the help of vertical line. But how to check graphically whether the function is one to one or many to one? For example, again the same diagrams. Here we have another test with the name of horizontal line test. You draw the line horizontally. You see, if I draw on every graph like I did in the previous slide, the vertical line intersecting only at one point. If I draw the line horizontally, in this case the line horizontally intersecting only at one point, here also only at one point. If I draw any other line horizontal, it will cut only at one point. Here also you see only at one point. So these three are the example of one-to-one function. Therefore, every y you have one x also. For function for every x you have unique y. But if you have for every y you have unique input, it is called a one-to-one function. So these three graphs representing one-to-one function, and it's called horizontal line test. In the remaining three graphs, you have one value of y but corresponding multiple value of x. Like in this case, for this value of y, you may have x positive, you may have x negative. With this value of y, you may have x one value or the other value, suppose this one or the other value, this one, or four more values. So these three are the many to one function. Please take some time, pause the video, get the idea clear, note down these graphs, and then move forward. You should be having a very clear idea in your mind about the types of functions also. Hopefully the idea is clear. Okay students, now we have an example here to give you an idea about the range of a function. Make it a habit that whenever you have a question function, try to sketch the graph. Please sketch the graph, and you need to learn few basic sketches. Linear, straight line, the quadratic, graph of 1 over x, graph of 1 over x square, the graph of cubic, sine, cos, tan functions. These are the part of your P1 syllabus. Now we have here a linear graph, and if you draw this with the domain restricted here, domain means x value, input value, it's more than equal to 5. If I draw the straight line, line has no endpoint, but I need to show the graph from 5 or onwards, like this 5 onwards. You see the graph here, this portion. So my domain is 5 onwards, from starting from here. So if input is 5, your y value is 10, and we are moving up, so it means the range is more than or equal to 10. Is that clear? So your range is more than or equal to 10. This way you write the range. Range means the y value. Hopefully the idea is clear. Now moving forward, another example. See here, graph is cubic, x cube. You have done this graph in your O level. This is the shape of the graph of x cube. But you need to sketch between the domain of -2 to 4. You see, with -2 you have sign of equality, but with 4 it's just inequality. Please note down these things. Domain here also restricted. It's not for all real number. How to find the range? Draw the graph. Just free sketch, a roughly sketch. Your domain from -2 to +4. You see these 2 points? -2 to +4. So if I find the range for -2, input -2 here, you get -8 corresponding to this. When you input 4 here, you get 4 cube 64. So you have 8 and 64. See here. But 8 is inclusive. You see, I've shown here a hole. This hole representing that this point is not inclusive. It's not 64 but less than 64. That can be 63.9999 or something like that, but not inclusive of 64. So you have to write the range in this way. You see here, no sign of inequality. So no sign of equality here. This is the range of the graph. The y value, the least is -8, the highest is 64, like this. Hopefully the idea is clear about the range, the y value. Another example, a very commonly asked question in examination, a quadratic graph. First of all, we need to express in this perfect square or completing square format. and you should know few, or you should learn few steps. I'm sure all of you know how to convert in this form. You have two ways, one by technique of comparison or by completing square method. I've taken two common. First of all, I've taken two common. Then whatever the number here, this, think half of that number, because this is equal to twice AB. So half of that number is 3. Add and subtract square of 3. First three number always form the perfect square like this. And finally you get minus 9 plus 11, that becomes 2. Now open the bracket, 2 into 4. I've transformed this into completing square form. We'll be discussing this concept in detail when we start the transformation of the graphs. We'll discuss this further when we're doing transformation also. All of you should know, whenever you have this form, x minus h whole square plus k, h and k representing stationary point, turning point, x value of turning point and the y value of turning point, and it is for all real domain. Domain is not restricted, but range is restricted here. So we have done the first part. What about the second part? Again, my idea is to sketch the graph first. So you got turning point here, and this turning point show that least value of y is 4. So your range is y value is 4 or up. That is, you write the range in this form. It's more than or equal to 4. Pause the video here. Repeat this part, because this is very commonly tested question or type of question in the examination. And please learn how to sketch. We'll be doing the same thing again when we do the transformation, especially the translation part. Now, another idea, how to find the domain of function. If you have the range available, you see here the range is there, the y value. Y is more than equal to 5, but about the domain. Student, please note down few things. The graph of 1 over x, please note down. This is the graph of 1 over x. What about graph of 1 over x square? The graph of 1 over x square. And in these two graphs you have asymptotes. In this graph again the asymptote is x-axis and the y-axis, same as here. And then we'll be learning in transformation. With this minus 2, it means you shift the graph 2 units towards right. Now asymptote from y-axis now moves to x2, and you have something like this. This graph is moved rightward 2 units. This is not the topic of the first lecture, first video. We'll be discussing this in the second video, the transformation. But you should be getting this basic idea clear, having this basic idea clear, how to move the graph rightward or leftward. Whatever the sign you see here, when you add a constant to x, you always move the graph opposite to that sign. But for this you need to learn the basic graph. So first I have to draw the graph of 1 over x square and then move the graph towards right. This way, let me show the graph first. Wait, yeah, this is my graph. Let me remove this part. So I have not shown the complete picture. It must be moving like this, downwards, suppose like this. Asymptote is here, and this is asymptote now at x value 2, because when I put 2 here, 2 minus 2 is undefined. So how I'm solving this? I put the function value 5 here. 5 cancel, you get 1 here. Root of 1 is plus and minus. X minus 2 is either 1 or minus 1. Shift 2 there, you get 3 and 1. It means your domain value between 3 and 1. So but I can't say this is the value of 5. Use the value of 5. You see 5 here, and we are saying the range is above 5, the graph is above 5. It means something like this, something moving up. But I can't take the domain from 1 to 3, because there is a point or a line here where the curve is not defined. So when the range is more than 5, you want the graph above this line. You need to find the domain value. You are getting 1 and 3. So you can't write simply saying like this. Simply saying between 1 and 3. You have to mention this also. Because when you put 2 here, this function, when you put 2 here, 2 minus 2 is 0, anything upon 0 undefined. So if you say your domain is between 1 and 3, this is not the correct answer. And 1 and 3 should be, there's a mistake here in the answer, that should be inclusive. Why inclusive? Because 5 having this equality also. I should write 1 less than equal to x less than equal to 3, but not 2. Every point in this region giving you the domain of the function, that is, you can input any value in the function between 1 and 3 and you get result above 5, but except 2. Pause the video here, repeat this example. This is a very technical and good example to get the idea clear. Moving forward, now student, my next idea is about the composite functions. And what are composite functions and how we deal with these composite functions. Composite functions are formed when two functions in which one result of one function becomes the input of the other function. That is, you input your domain into one function, that will give you an output. That output becomes the input of the next function. This way you can have a composite function, and composite function may be possible for more than two functions also, right? And please do not confuse with this symbol. If you have f of x and then g of x, it means multiplying two functions. But when you write this f of g of x, it means you are making a composite function where g in this case is known as the inner function. This is called as the inner function. Is this clear? Now, the composite function means apply g first, then followed by f. This is very important, in which sequence the function is working. For example, if we have f of g, if you show this mapping concept, what happens? This input goes to function g first. It has certain output, which is g of x. That becomes the input into the function of f, and ultimately you have f of g. This way you have the process. Always move in the backward direction. Now you can see the diagram as well. There are two functions and I have combined these two as into a single function, and see the order also. And so always treat function like a machine. That's a better idea to understand this concept. You see that a bigger machine of f of g containing two processes or machines inside, but in the opposite direction. First g, then f. So input goes to the machine g or the function g, whose output goes to the function f, and then you get f of g. Is that clear? This is called the composite function. And very important concept, and this has been tested in the examination so many times, that f of g exists only when the range of g, meaning output of this function, output of g, contained within the domain of f, output falls in the domain of f. If suppose f has a condition that for all positive values, suppose f has a condition of input or domain of all positive value, and g is giving you some negative value, it means f of g is not possible. In that case, it's very important to form a composite function that the range of the inner function or the first function or its output must fall within the domain of the second function or the outer function. Note down this property. When you attend my session, we will be discussing or solving past papers question based on this concept. Please note down this. Now moving forward further, these are the few steps in case of composite function. Composite function f of g or f of g of x, same thing. Inner function is gx. How do you read this f of g of x? And in general, f of g is not same as g of f. If you change the order of composition, the result is not same in general. There are exceptions also, but in general the two are not same. Examples. I have function here x cube f of x, function here g of x, x plus 2, linear and cubic. I want to make a composite function. It means I need to make some inputs in the function of g first, that is x plus 2, whose output will be transferred into the function of fx, that is x cube, and then you get f of g. So see here, when I say f of g, I replace g by x plus 2. This is x plus 2 in the function of f. So replacing that x value by g, which is x plus 2. cube it, simplify it, get the result. This way you can make a composite function. The idea is clear. I've shown in detail the steps here, right? Okay. Another example, we have function f 3x plus 2 and g x minus 7, both having domain all real number. Any number can be used as a domain, a real number. F of g means, see here, in the function of f, replace x by this g function. G is 7 minus x. So that should be replaced in the function of x. Replace x in the function of f by 7 minus x. Now you will be seeing this 3 into 7 minus x, simplify it, solve it, and get the composite function. What about f of fx? You may write this as f2x like this, both having same meaning. It does not mean the square of function. So we input in the function of f again the whole function of f. F is 3x plus 2. I've replaced in place of fx 3x plus 2. In the function of x, that is 3 times, you see 3 times 3x plus 2, simplify it, 3 into 3, 9, and then you will get the required result. Now the next part requires g of f, order is changed and equate it to 2x if. So g of f means in the function of g, replace x by f. In the function of g, replace this x by f. Simplify it, I'm getting 5 minus 3x. Now examiner is saying solve the equation if this g of f composite function equals to 2x. So I've equated this by 2x. Now solve this and get the result. Hopefully the idea is clear to all the students. X is 1. More examples of composite function. Fx is 4x minus 1. Gx is 1 over x plus 2. But we have a condition for the domain. Domain can't be 2 or can't be negative 2. It should be negative 2 here. Domain can't be negative 2 because if I put negative 2 here, that becomes undefined. And same for h function, we have some domain there. Now f of g means you replace f in the function of f x by the function of g. See this? I've replaced this value. Composite function. And simplifying it, get the result where x can't be minus 2. Similarly, h of h means h2. Replacing the function h by the whole function again. In that function, replacing x by, right. So substituting the x value by 2 minus x, this 2 was there, and in place of this x, I've written as 2 minus x with square. Then we have whole square because of that. Simplify this, and ultimately when you open the bracket and you get this result, this is the result of h of hx. So we have more examples. I'm just showing you the solution here. You just pause the video and see the working before moving to the next slide. Please solve this. This is very well explained. You just go through it, pause it, write the result, write the working, and check your answer. The next concept in the chapter of function is the inverse of a function. How we define inverse of function and how we show the inverse of function graphically. The two things we are going to discuss here. So when we talk about the inverse of a function, it means we want a function that will undo the effect of function. An inverse function performs the opposite operation the original function. Opposite operation. For example, if you have a x square, so you need to find a function that will reverse it. Like if you see here, this is my function fx. Graphically, inverse function is basically the reflection of that function in the line y is equal to x. Please note down this very important property. Whenever you make inverse function graphically, what are you doing here? You are making a function that is obtained by reflecting the original function in the line y is equal to x. This graph is very important. Y is equal to x line here, and this was the function fx, and we got the f inverse x. And the symbol, a negative. Another important thing, whenever you do the reflection, suppose we have a function here, this is y is equal to x line, This is inverse function. So if the domain is suppose at any point x and y, so after reflection this y value becomes x for the inverse function and x value becomes the y of the inverse function. So can I say domain of fx become the range of f inverse and the range of fx become the domain of f inverse? These two are swapped. Domain of fx become the range of f inverse and the range of fx become the domain of f inverse. The diagram is clear. Now this is the suppose this is the range. Let's say it is -7. The range of function is more than -7. You see here the same is for domain value. Domain is more than -7. Please check this property. Whenever you have a function and whose inverse is to be drawn, you clearly observe this concept or this property. The range of fx becomes the domain of f inverse. And one important thing, inverse function exists only for a one-to-one function. Inverse only for one-to-one function. And I've shown again the concept of inverse with the help of a machine. You see here, you input x, you get some output, and whenever you input that output you get the reverse process and you get the same result what was the input at the beginning. This is a composite of f into f inverse. This is equal to x. Note down this important feature, f of f inverse is always x. Here this property is workable. If you change the order it's also same. In general, I've mentioned the last slide, fg is not same as g of f, but this is a special case. F of f inverse composite is same as f inverse of f, right? So inverse function will undo the process. Note down this concept in the diagram. And one important again thing, the inverse exists only for a one-to-one function. These are the steps how to make the inverse function. First of all, you express the function in terms of y, then you rearrange, that is you make subject x in terms of y, right? And then you swap the variables. I'm giving example here on this next slide. This is a function fx 3 over x minus 1. Your first step, write down y in terms of this. Then you see you have done the cross multiplication, see here. And the second step, you have expressed x in terms of y. Then swap the variable. So x becomes your f inverse function and 3 plus x over x, this is the inverse function. And whenever you write the inverse function, you need to check is there any condition where the function does not exist. You have to mention, you see here x can't be 0 because if you put x value 0 here, anything divided by 0 is infinite, undefined. Please try to get this idea how to make the inverse function. Sometimes it's not that much simple, especially in the case of quadratic function. When you're going to make the inverse, you need to do more steps. The idea is same, but the working requires more steps. Now we need to check whether the function is working or not. In the last example, your output, I showed again. You see here, the last example, 3 plus x over x is your inverse function and 3 over x minus 1 was the original function. Suppose in the inverse function, if I replace x by 1, 3 plus 1 upon 1, what do you get? See here, 3 plus 1 upon 1, you get 4. So if I input in the inverse function x, I get the output 4. Now that becomes the range of inverse and this is domain. Now if I move the reverse process, if I input the output of inverse function into the function f, that is domain of f becomes range of f inverse, I get the same result and which is same as the domain of f inverse, right? This way you can check whether the inverse function is working or not. The reverse process, this will undo the initial step. Clear? Now more examples of making the inverse function. You have function like this, x minus 2. You see you can't take the value of x less than 0 because that makes this result complex, not real. It's given there, domain is restricted here. Now we need to sketch the graph. We need to find the function which is inverse, domain and range, and we have to show the relationship between y and x. Student, please note down the best idea for this topic to get the concept clear is to sketch the graph whenever possible. So I've shown the graph of root x minus 2. If it is plus minus 2 x minus 2, that would have been like this. But since it is only plus root x minus 2, I show the positive part of the graph. You see the domain I've taken more than equal to 2. Domain is more than equal to 2. Now what's the range? You see the y value is least 0. Very clearly, very easily with the sketch you can say the range of the graph is y more than equal to 0. So sketching is the best tool for this topic. Now moving forward, if we want to make the inverse function, the steps are make subject x. So squaring both sides, I moved this over there on the other side. Ultimately, I got x equals to y squared plus 2. Now, if I swap the variables, so y becomes x squared plus 2, and this way you get the inverse function. Always write the inverse function in terms of x. It's a common practice. This function having domain x is more than equal to 2 and the range y is more than equal to 0. So range of the function becomes the domain of the inverse function. You see here the domain. Please note down this property. And the domain of the function becomes the range of the inverse function. It's a very clear example, a question like examination question. You find such question in the past papers also. Please spend few minutes on this slide, get the idea clear about the domain and range of the function and the inverse function and the process and the graph and how to show the y is equal to x line. Whenever you have to make the inverse function, you need to show this line y is equal to x also. That shows clearly the reflection in the line y is equal to x, and this is your inverse function in the graph. You see the range is more than 2, and here is for the domain which is more than equal to 2. More examples. Your function 3x minus 4, a linear function. This is 1 over x plus 1. Now you have to find the inverse of these two functions. How to find the inverse? The steps are there. First step, second step, third step. Please see this and get the function. I've written this 3x minus 4 as y. I've given the name y to this, right? I change the variable, writing x here and y. Then I make subject y and I got the result. Similarly, if I do the example number 2, the g inverse, the same steps. You see here, I've given the name of this function y, swap the variable, and then make subject y over here, and y is equal to 1 minus x over x. That becomes your g inverse of x. Practice, draw the diagrams. The diagram is very simple for this f inverse. This having a gradient 3 and intercept minus 4. Suppose I draw this somewhere, no space over here. I'm drawing here this graph minus 4, 1, 2, 3, 4. This is negative 4, and suppose the graph is something like this, straight line. It's the graph here of fx. Then you have to show this y is equal to x line every time, and then reflection. This minus 4 comes here, and you should draw the graph like this, reflection. Draw neat graph, scale diagram, and use ruler to draw the lines. Now we have x squared plus 1, and draw the graph of this. Now if you are drawing the complete function, please pay attention. This will not be giving you an inverse, because inverse exists only for a one-to-one function. Remember this point. Inverse exists only for a one-to-one function, not for many-to-one function. So this is the important property you should learn. So either you are drawing the graph to the extent of this turning point maximum, less than 0 or more than 0. If you draw the graph up to something above or beyond 0 like this, it will not be having inverse, because if I draw a line horizontally, it is not a one-to-one function. We have discussed this concept of horizontal line test. Inverse function existing only for a one-to-one function. So if I've made the domain restricted. Suppose my domain is x is more than equal to 0 like this. This is 0 here, x0. I've drawn this part of the graph. And you see the range is more than equal to 1. Now, how to sketch its inverse? First of all, you need to draw the line y is equal to x and show the reflection. That range becomes the domain here, and you have a graph of this shape. See here. A very clear reflection. The range becomes the domain of inverse function. Is this clear? Note down this, draw this, pause the video, then move forward. A similar example, we have x squared minus 6x plus 2. Now student, never attempt to make subject x. If you start like this, y equals to x squared minus 6x plus 2 and try to get x as a subject, you can't. You need to convert this quadratic into completing square form first. You see, I have made the completing square form. You have done this in the chapter of quadratics, how to convert into completing square form. And when you have this, these two numbers will give you an idea about the turning point or stationary point. In my example, 3 and negative 7. See here, this is 3 and negative 7. X is 3 and y is negative 7. Turning point. Examiner has mentioned that function has the domain restricted. X is less than equal to a, or maximum value of x is a. Find the value of a for which inverse exists. Obviously, this is 3 here. If I draw this part of the function only toward the lower side, this will satisfy the condition of a one-to-one function. Because if I draw anywhere the line horizontally, that line will cut only at one point. So inverse existing only for a one-to-one function. Now we can make the inverse function here. How to make the inverse function? If you write y equals to x minus 3 whole square minus 7, then you get x minus 3 whole square is equal to y plus 7. Please pay attention. X minus 3 is equal to under root y plus 7. Now the sign before this root is again important, and that sign is governed by this inequality of the domain. Please pay attention. If it is less than for domain, you need to put a negative sign here. If it is more than, in that case, a positive sign. Finally, we have 3 minus under root y plus 7. That is, I can write 3 minus under root x plus 7, swapping the variables, and you get f inverse x. You got the idea how to make the inverse function of a quadratic function. If the domain is restricted and the function is one-to-one, every quadratic function not having the inverse function, for example, if I draw this completely like this and try to make some inverse function, something, suppose something like this, this is not inverse function, because if I draw a vertical line here, that line will cut at 2 points and not satisfying the definition of the function. The inverse only exists for a one-to-one function. Is that clear? Now, how to show its diagram, the image of the fx, which is the inverse function, like this reflection. You see the domain was less than 3. This is 3 here. Domain is less than 3. And here is the same value for range of y of inverse function. 3 is this, is less than 3. The range of this function is above negative 7. Above negative 7. The domain of this function is above negative 7. Please note down this property and draw the graph yourself. You get the idea clear about the inverse of a function. I've given the example of quadratic. The same thing again here. Suppose examiner is saying domain is restricted, already mentioned, more than equal to 0. This part only 0 is here. So how to make the inverse function? First of all, you need to convert into range is more than equal to what? Minus 2 to infinity. You can write this way also. Okay, range of function is more than or equal to minus 2. Minus 2. And this way you can draw the inverse function. Is that clear? How to sketch the graph inverse function. We have done few examples, and remaining example we'll be discussing while having the online session live. You can check this also. At the point of intersection, you see that property f of f inverse is equal to what? X. At this point of intersection, you want to find this point. If you want to form this point here, and at this point the function is intersecting y is equal to x line. That's why I've equated this with x. You see this idea in the examination. If the examiner is asking find the point of intersection, you simply equate a function or the inverse y is equal to x, then solve that and get the result. Or you can equate inverse function by function as well, because here the two functions are intersecting, right? So this is the end of my first video as a pre-workshop material, and please go through this before attending the session. It's very important, because when you join my session you have a clear idea about the function, about the sketches, about the domain, about the range, about the one-to-one function, many-to-one function, the vertical line test, inverse function, the composite function, the condition for inverse and the condition for composite. Then you will really get the benefit of that session. So hopefully to meet you on 5th of April, when we have the session. Mainly we will be discussing the past papers questions on this topic of function. Thank you, dear. Enjoy your learning.